Why is the sky blue? To answer that question, we first need to understand something even more important. What is science? Our world is covered in questions. Why do volcanoes erupt? What is life made of? How do stars and galaxies form? Who is in control of our mind? Science is how we search for those answers. First, let's define our words. Science is a process for understanding the natural world through observation, evidence, testing, and revision. Questions are answered by science through the scientific method, something you do probably more than you think. The scientific method is a framework for asking questions, testing ideas, and following where the evidence leads. It breaks down into a few different steps. Step 1. Observation. I can observe that the sky is blue. Step 2. Question. Why is the sky blue? Why is it not always red? Why don't we ever see it green? Step 3. Hypothesis. A hypothesis is a proposed explanation for a phenomenon. You might say to yourself, I think the sky is blue because the ocean reflects onto the sky, turning it blue like a giant mirror. Or ancient volcanoes release blue gases that permanently stain the atmosphere. Or even possibly, the sky is actually a giant blue dome surrounding the Earth. Yeah, probably not that one. Step 4. Experiment. An experiment is a test designed to see whether evidence supports or contradicts a hypothesis. There are many different types of experiments. Most often, an experiment is a way of testing an idea by changing something and observing what happens. Imagine you're driving to school or work and wonder if there's a faster route. One morning, you take a different road and compare how long it takes. If it's faster, you might start using that route instead. That's an experiment. You had a question, tested an idea, observed the results, and used the evidence to make a decision. Let's connect that to our example now. Scientist number 1 states, I think the sky is blue because the ocean reflects onto the sky, turning it blue like a giant mirror. A prediction can be made that if this were true, places far away from the ocean should have a much less blue sky. However, this is not what we observe. Here you can see the Sahara Desert, the Rocky Mountains of North America, and the Mykonos coastline of Greece. All have blue skies despite being varying distances from the water. The prediction is not supported by observation. Our second scientist states that ancient volcanoes release blue gases that permanently stain the atmosphere. A prediction can be made that if the atmosphere were actually stained blue, we should find blue colored gases when we analyze the air. Scientists have done exactly this and found the atmosphere to be made of nitrogen at 78%, oxygen at 21%, argon at about 1%, and other trace elements at less than 1%. Scientists know the properties of these gases, and we know they are colorless. The evidence does not support the hypothesis. Our third scientist thinks the sky is actually a giant blue dome surrounding the Earth. At first, the idea of a giant blue dome surrounding Earth might sound ridiculous, but science doesn't reject an idea because it sounds strange. It asks one simple question: what does the evidence say? Humans have launched thousands of satellites and spacecraft. Astronauts travel through the atmosphere into space without encountering any dome. Therefore, the hypothesis doesn't match observations. Each of these hypotheses sound reasonable at first, but science isn't about choosing the explanation we like best. It's about testing ideas against reality. So scientists propose another hypothesis. What if the atmosphere itself isn't blue, but instead scatters blue light more than the other colors? To test it, they shined white light through gases and carefully measured how each color behaved. Step 5. Analyzing the results. The color we perceive depends on the wavelength of the light entering our eyes. Scientists measured how different colors of visible light scattered as they passed through gases similar to Earth's atmosphere. They found that blue light scattered much more than the other visible colors. When they compared those results with the observations of the real sky, the evidence matched their prediction. The same explanation also predicted something else. Sunsets. When the sun is low on the horizon during sunrise and sunset, its light must travel through much more of the Earth's atmosphere. Most of the blue light is scattered away before it reaches your eyes, leaving behind more of the red and orange light. Once again, the prediction matched what we observe in the real world. So scientists came up with a hypothesis. tested the hypothesis with an experiment, analyzed the results of the experiment. Scientists now apply it to the question at hand. Step 6. Drawing a conclusion. Drawing a conclusion is deciding whether the evidence supports or does not support your hypothesis. Using our sky example, a scientist will draw a conclusion that looks something like the experimental results matched our observations of the sky. Therefore, the evidence supports the hypothesis that Earth's atmosphere scatters shorter wavelengths of visible light more efficiently than longer wavelengths. Supported versus proven is an important distinction to make here. In science, evidence can support an idea very strongly, but scientists are always willing to change their understanding if new evidence is discovered. Now for our final step. Step 7. Sharing the results. This step is often overlooked, but is actually one of the most important. Publishing a scientific discovery doesn't make it true. It invites the rest of the scientific community to examine it, question it, and try to reproduce it. The more a discovery survives that scrutiny, the more confidence scientists have in it. Science isn't done in secret. Discoveries become stronger when other scientists can test them for themselves. The scientific method is not a rigid checklist, but rather a framework for asking questions, testing ideas, and following the evidence wherever it leads. Before we end, it's just as important to understand what science is not. Science is not a collection of facts to memorize. Facts are the result of science, not science itself. Science is not a belief system. You don't have to believe something simply because a scientist says it. Scientific ideas earn confidence by repeatedly matching the evidence. Science is not perfect. Scientists make mistakes, experiments can be flawed, and our understanding changes as new evidence is discovered. Science is not about having all the answers. Some questions have well established explanations, while others remain active areas of research. Modern science is remarkably young. In just a few hundred years, it has taken us from wondering what the stars are to walking on the moon, from mysterious illnesses to life saving medicines, and from invisible atoms to the building blocks of life. If this is what we've learned in such a short time, imagine what there's still left to discover. On this channel, we'll explore the questions, follow the evidence, celebrate what we know, and be honest about what we don't. Stay curious.